There are crime scenes in the cosmos. Vast, silent, and frozen in the amber of deep time, they hang in the void as beautiful, chilling testaments to acts of unimaginable violence. We are detectives of deep space, and our only evidence is light, a faint whisper that has traveled for an eternity to reach us. Our case file today concerns a victim and a perpetrator, a mystery 500 million years old. The scene of this cosmic transgression is a celestial masterpiece, an object so strange, so perfectly and violently symmetrical that it defies our neat categorization of the heavens. Suspended in the constellation Sculptor is a phantom, a ghost of a galaxy punched clean through its heart, leaving behind an incandescent ring of fire. We call it the Cartwheel. To truly comprehend its bizarre nature, you must first forget what you think a galaxy is supposed to look like. Erase from your mind the majestic swirling arms of a spiral galaxy like our own Milky Way, those grand luminous rivers of gas and dust where stars are born in gentle, predictable eddies. Those galaxies are elegant, orderly cities of light, spinning with a gravitational grace that has been perfected over billions of years. Their spiral arms are the bustling boulevards crowded with stellar nurseries and glittering with the light of young, ambitious suns. They are dynamic yet stable, a testament to the organizing power of gravity and dark matter, a cosmic dance of sublime choreography. The grand designed spirals in particular are the aristocrats of the Galactic kingdom, their structures so refined, so exquisitely defined, that they seem almost deliberately sculpted. They represent a kind of cosmic equilibrium, a state of mature beauty that countless galaxies strive for. We look at Andromeda, our nearest major neighbor, and we see a portrait of cosmic elegance, a spinning disk of 1 trillion stars held in a delicate, luminous embrace. This is our standard, our celestial archetype. Then there are the other galactic titans, the ellipticals. These are the ancient megalopolises of the universe, colossal, featureless swarms of aging stars. Imagine a beehive of light, a sphere, or an elongated football of tightly packed golden suns containing trillions of stellar citizens. These galaxies are old, their glory days of frantic starbirth long since past. They have settled into a quiet, stately retirement. There are no dramatic spiral arms here, no vibrant nebulae painting the void with pink and blue hues. Instead, there is a serene, uniform glow, the combined light of ancient stars that have been orbiting a common center for eons. Ellipticals are the universe's quiet giants, the repositories of cosmic history formed from the chaotic mergers of smaller galaxies in the universe's youth. They are monuments to a more violent past now existing in a state of tranquil grandeur. They are the end of one evolutionary path, a vision of what our own galaxy might become in the far distant future, after its own eventual collision with Andromeda. These two great families, the spirals and the ellipticals, along with their smaller, more chaotic, irregular cousins, make up the vast majority of the galactic population. They are the known world, the catalogued species in our cosmic bestiary. And then there is this. The Cartwheel belongs to none of these families. It is an anomaly, a spectacular aberration that breaks every rule. 500 million light-years away, it floats in splendid isolation, a cosmic bullseye painted on the fabric of space-time. It is not a spiral, for its delicate arms have been utterly obliterated, violently rearranged into something new and terrifyingly beautiful. It is not an elliptical, for it is not a quiet sphere of old stars, but an object blazing with the fire of furious ongoing creation. It is a spectacle of rebirth, a phoenix forged in a cataclysm. The galaxy presents itself to us as two concentric rings, a smaller, denser inner ring surrounding a shattered skeletal core and a vast, brilliant outer ring connected by faint, ghostly spokes of dust and gas. This outer ring, 150,000 light-years across larger than our entire Milky Way, is the galaxy's defining feature. It is a perfect, shimmering circle of stellar genesis. It is a tsunami of star formation, a shockwave of matter and energy propagating outwards through the void at over 200,000 miles per hour. This is the heart of the enigma. That ring is not a static structure. It is the ripple frozen in our moment of observation from a stone that was cast into the cosmic pond 500 million years ago. This entire magnificent structure is the immediate explosive aftermath of a head-on collision. Another galaxy acted as a cosmic bullet traveling at immense speed and plunged directly through the center of what was once a normal spiral galaxy. The impact was not an explosion in the traditional sense. Galaxies are mostly empty space, so stars themselves rarely collide. Instead, it was a gravitational disruption of supreme and terrifying power. The Intruder Galaxy, a smaller and more compact entity, created a powerful gravitational ripple, a density wave that began to expand outwards from the point of impact like a sonic boom. This wave, this celestial tsunami, swept through the victim galaxy's vast disk of gas and dust. As it expanded, it compressed the interstellar medium, squeezing immense clouds of hydrogen gas until they collapsed under their own gravity, triggering a colossal burst of star formation on a scale that is almost impossible to comprehend. The outer ring is where that shockwave is today. It is a wall of fire and creation. The brilliant blue-white light that dominates its structure is the telltale sign of this process. It is the signature glow of massive hot young stars, stellar giants, many times the mass of our own Sunday. These are the ephemeral titans of the cosmos. They burn through their nuclear fuel with profligate intensity, living short, spectacular lives before exploding as brilliant supernovae. Their presence tells us with absolute certainty that this ring is a newborn structure, a fleeting moment of brilliance in the galaxy's long life. We are witnessing a wave of creation and destruction sweeping through the galaxy. Inside this ring of fire, the galaxy is attempting to reform. The faint spokes, like the spokes of a celestial wagon wheel, are theorized to be the gravitational pathways along which matter is beginning to recoalesce, the first tentative efforts of a shattered galaxy to regrow its spiral arms. They are the scars and the sinews of a system tearing itself apart and trying to stitch itself back together simultaneously. The inner ring closer to the wounded core is a secondary ripple, a smaller echo of the main event, glowing with the light of slightly older stars that were born in the first moments after the cataclysmic impact. This entire celestial object, therefore, is not just a place, it is an event. It is a snapshot of a process, a single frame in a film of cosmic violence. And this presents us with the central, tantalizing question that will drive our investigation. Who was the culprit? What was the bullet? A collision of this perfection, a direct bullseye, is extraordinarily rare. The Intruder Galaxy, having passed through the heart of the Cartwheel, would have continued on its journey, a ghost slipping away from the scene of the crime. Finding it is the ultimate challenge for cosmic forensics. Looking around the Cartwheel, astronomers have identified several potential suspects, smaller companion galaxies caught in the larger galaxy's gravitational pull. Is one of them the hit-and-run driver, the phantom that instigated this stunning transformation? Or has the perpetrator long since fled the scene, now hundreds of millions of light-years away, forever beyond our reach? Evidence is subtle, encoded in the precise shape of the ring, the stick velocity of the expanding gas, and the faint gravitational tendrils that may still connect the victim to its attacker. To unravel this mystery, we must become forensic astronomers. We must look beyond what our eyes can see, for the most crucial clues are hidden in invisible light. We will use the penetrating gaze of our most powerful telescope's instruments that can see the universe in wavelengths far beyond the visible spectrum. We will look in the infrared with the James Webb Space Telescope to pierce through the dense clouds of dust and see the nascent stars being born within the fiery ring, witnessing the process of creation as it happens. We will turn to the X-ray vision of observatories like Chandra to trace the superheated gas, the million-degree plasma that is the lingering heat signature of the collision's shockwave, and to spot the black holes and neutron stars left behind by the exploding giant stars. Each wavelength of light tells a different part of the story, revealing another layer of the crime scene. We will sift through this multispectral evidence using computer simulations to recreate the impact, running the cosmic clock backwards to test our hypotheses. We will model different types of collisions, varying the mass of the intruder, its speed, its angle of impact, until we find a scenario that perfectly reproduces the ghostly rings and fragile spokes we see today. This journey is about more than just solving a single cosmic puzzle. The Cartwheel Galaxy is a unique and precious laboratory. It allows us to study the violent processes that shape the universe on the grandest scales. Galactic collisions are not rare. In fact, they are a fundamental part of cosmic evolution. Our own Milky Way is the product of countless mergers with smaller galaxies and is on a collision course with Andromeda. But rarely do we get to see the process so clearly, so cleanly, and in such a spectacular phase. The Cartwheel is a living experiment in starburst physics and galactic dynamics. It teaches us how galaxies respond to extreme trauma, how they can be torn asunder, and then begin the slow, arduous process of rebuilding. It is a stark reminder that the universe is not a static, peaceful place. It is a realm of unimaginable energy and constant, violent change, where creation is born from destruction. It forces us to confront the fact that the elegant spirals and sedate ellipticals we see are not the full story. They are merely the survivors, the ones that have found a fragile peace. The Cartwheel shows us the raw, untamed power that sculpts the cosmos. So come with us as we step across 500 million years of space-time. The evidence is waiting. The ring of fire beckons. We are going to hunt for a ghost, and in doing so, we will uncover the story of how to create one of the most beautiful and violent objects in the entire universe. In a universe we believe is governed by the elegant waltz of gravity, a cosmos where swirling galaxies unfurl their spiral arms with the precision of a mathematical formula, what happens when something shatters the dance? For eons we have looked to the heavens and found a comforting sense of order, a grand celestial architecture built from predictable shapes. There are the great rivers of stars, the spiral galaxies like our own Milky Way pinwheeling through the darkness in a stately procession. There are the vast luminous clouds of the elliptical's ancient cosmic cities glowing with the embers of 1 trillion old suns. And then there are the irregulars, the scattered and the small cosmic dust bunnies swept into the corners of space. For decades, this was our map of the universe, our neat and tidy catalogue of everything that was. We built our theories of galactic life and death upon this foundation, believing we understood the fundamental ways in which these immense structures were born, how they lived, and how they would eventually fade. But the cosmos, in its infinite and often violent imagination, has a way of reminding us that our maps are always incomplete, that our rulebooks are merely drafts waiting for a radical revision. It reminds us that for every elegant waltz there is a collision, a cataclysm, an event so powerful it rips the very fabric of a galaxy apart and reshapes it into something utterly new, something monstrously beautiful. The story of one such revision, one such cosmic monster begins not with a grand announcement, but with a flicker of confusion, a smudge on a piece of glass in the cold, quiet dark of a mountain observatory. It begins with a man as iconoclastic and brilliant as the objects he hunted in the night. His name was Fritz Zwicky, a Bulgarian-born Swiss astronomer working at the California Institute of Technology. Zwicky was a force of nature, a mind of staggering genius, housed within a notoriously cantankerous personality. He was a man who famously referred to his colleagues as spherical bastards because, as he put it, they were bastards no matter which way you looked at them. Yet this abrasive visionary possessed an intuition for the cosmos that was second to none. He was the first to infer the existence of dark matter, the first to correctly theorize that supernovae were the death cries of massive stars collapsing into neutron stars, and he dedicated a significant portion of his life to a monumental task cataloging the universe's largest structures. In the 1,940 seconds from the lonely perch of the Palomar Observatory in Southern California, Zwicky embarked on a comprehensive photographic survey of the northern sky. Night after night, the 18-inch Schmidt telescope would open its eye to the heavens, capturing vast swathes of the cosmos on large, delicate photographic plates. This was astronomy in its rawest form, a painstaking process of exposing light-sensitive emulsions to the faint ancient light of distant galaxies for hours on end. The resulting plates were not the crisp, colourful digital images we are accustomed to today. They were ghostly negatives, a monochrome tapestry of black space peppered with white specks. Each speck was a star. Each faint, fuzzy smudge was an entire galaxy, an island of billions of stars, floating millions of light-years away. Zwicky's goal was to create a comprehensive atlas, the Times Catalogue of Galaxies and of Clusters of Galaxies ***. He and his small team would spend their days hunched over these plates with magnifying glasses, their eyes tracing the faint patterns of light, classifying each smudge according to its shape and brightness. It was a colossal, almost Sisyphean undertaking, sifting through the cosmic static in search of order. They were looking for the familiar spirals, the puffy ellipticals, the telltale signs of galactic clusters gravitationally bound together. It was meticulous, often tedious work. But on one of those plates, among the thousands of unremarkable smudges, lay something that defied all classification. It was a ghost, a whisper, a shape so bizarre, so profoundly strange, that it must have stopped Zwicky in his tracks. There, embedded in the emulsion, was not a spiral, not an elliptical, but a ring, a perfect luminous circle of light surrounding a displaced brilliant core. It looked less like a galaxy and more like a target painted on the fabric of the cosmos, a cosmic bullseye daring someone to explain it. Zwicky, with his characteristic brevity, simply catalogued it as an object of interest, one of many peculiar finds in his vast collection. He had found so many strange things in the sky that one more anomaly, however striking, was perhaps just another Tuesday for him. He and his colleagues noted it as a prime example of an interacting system, a hint that some violent encounter had taken place. But the technology of the day could offer no further insight. The object was too faint, too distant, its secrets locked away in a whisper of light. For decades, it remained little more than a curiosity, a footnote in a vast catalogue, a puzzle box left unopened on the celestial shelf. It wasn't until the 1,970 seconds, with a new generation of more powerful telescopes, that astronomers revisited this cosmic spectre, and it was then that its true nature and a more fitting name began to emerge. They called it the Cartwheel Galaxy. To truly grasp the shock of the cartwheel, you must first understand the world it shattered. You must journey into the mind of an astronomer in the mid-20th century and see the universe as they did. For them, the cosmos was a grand but orderly zoo of galactic forms, beautifully organized by the pioneering work of Edwin Hubble. In the 1,920 seconds and 30 seconds, Hubble had done for galaxies what Carl Linnaeus did for life on Earth. He gave them a system of classification, a family tree. This system, known as the Hubble sequence, or the tuning fork diagram, became the bedrock of extragalactic astronomy. It was a powerful tool that suggested not just a method of sorting, but a potential pathway for galactic evolution itself, a story of how galaxies might change over cosmic time. On one prong of this conceptual tuning fork, you have the spiral galaxies. These are the celestial darlings, the supermodels of the cosmos. Structures like our own Milky Way or the magnificent Andromeda Galaxy are defined by their breathtaking spiral arms, luminous highways of gas, dust, and brilliant young blue stars, all swirling around a dense, bright central bulge, typically populated by older, yellower stars. These arms are cosmic nurseries, regions of intense star formation, where new suns are being born by the thousands. They are dynamic, vibrant, and incredibly common. We see them everywhere we look, a testament to the elegant efficiency of gravity and angular momentum. They are the benchmark of a mature, thriving galaxy. On the other prong of the tuning fork, you find the elliptical galaxies. If spirals are bustling cosmic cities, ellipticals are the ancient, quiet suburbs. They are colossal, often featureless spheres or ovoids of light, containing trillions of old red stars moving in largely random orbits like a swarm of bees trapped in a gravitational jar. They lack the cold gas and dust necessary to form new stars, so their star-birthing days are long over. They glow with a serene uniform light, the collected embers of a stellar population that ignited billions of years ago. These are the elder statesmen of the universe, the end product many thought of galactic evolution formed from the chaotic mergers of smaller galaxies. Connecting these two main types at the handle of the tuning fork were the lenticulars. These galaxies represented a fascinating intermediate stage. They possess the large central bulge and a flattened disk, characteristic of a spiral, but they are almost entirely devoid of spiral arms and the gas needed for star formation, much like an elliptical. They are smooth, lens-shaped objects like a spiral galaxy that has exhausted its fuel or has been stripped of its creative potential. And then, of course, there were the irregulars, a catch-all category for the misfits and the misshapen galaxies that displayed no discernible spiral or elliptical structure. These were often smaller, messier systems, perhaps disrupted by gravitational encounters or simply too small to have settled into a more organized state. This was the universe we thought we knew, a place of spirals, ellipticals, lenticulars, and their less organized cousins. It was a system that made sense. You could imagine a story playing out over billions of years. Chaotic clouds of gas collapse to form spirals which then gracefully use up their fuel or merge violently to become the great quiescent ellipticals. Every new galaxy discovered by astronomers like Zwicky could, with few exceptions, be placed somewhere within this framework. It was a comforting, predictable cosmic ecology, and into this neat, orderly zoo the Cartwheel Galaxy crashed like a meteorite. It fit nowhere. It obeyed none of the rules. It was not a spiral, for its brilliant ring of star formation was completely detached from its core, a feature never before seen. The classic spiral arms, those graceful winding rivers of stars, were completely absent. In their place was this impossible expanding circle of light, a shockwave of creation propagating outwards through empty space. It was not an elliptical, as it was bursting with the vibrant blue light of massive young newborn stars, the very signature of frantic ongoing star formation that ellipticals conspicuously lack. Its structure was anything but a smooth, uniform swarm. It was a system of distinct, violent components, a bright off-center core, a faint inner ring of older stars, and that spectacular blazing outer ring. This wasn't a quiescent cosmic suburb, it was a celestial explosion frozen in time. Nor could you simply dismiss it as an irregular galaxy. Irregular galaxies are defined by their lack of symmetry, their chaotic and jumbled appearance. The Cartwheel, however, possessed a terrifying, beautiful symmetry of its own. It was the symmetry of a ripple spreading across a pond, the symmetry of a shockwave expanding from a blast. It was a structure born not of gentle evolution or simple chaos, but of a singular cataclysmic event. It was a new class of object entirely, what would come to be known as a ring galaxy. And it was extraordinarily rare. For every 10,000 galaxies we catalogue, perhaps only 1 or 2 will exhibit this bizarre ringed structure. Their scarcity meant they weren't a standard part of the galactic life cycle. They were the products of a freak accident. The very existence of the Cartwheel posed a profound and troubling question to the astronomical community. The Hubble sequence was more than just a sorting tool. It was the foundation for our understanding of galaxy formation. It told a story of gravity slowly and patiently sculpting the cosmos. But the Cartwheel told a different story. It whispered of unimaginable violence, of galactic ballistics, of a celestial hit, and run on a scale that was difficult to even contemplate. Its structure was not the result of a slow evolutionary process. It was a scar. It was a wound. This single object, this faint smudge on Zwicky's plate, was a direct challenge to the established order. It demanded a new chapter in the story of the cosmos, a chapter filled with destruction and rebirth. It forced us to ask a question we had not seriously considered before. What kind of force, what kind of cosmic hammer could strike a galaxy with such power that it punches a hole right through its center, triggering a firestorm of star birth in an expanding ring of debris? What could possibly send the ripple of creation, a tsunami of gravity, hurtling through a galaxy at over 200,000 miles per hour? The neat and tidy models of galactic evolution had no answer. They accounted for graceful spirals and quiet ellipticals, for the slow dance of mergers over billions of years. They did not account for this celestial shotgun blast. The Cartwheel was an enigma, wrapped in a mystery, a cosmic crime scene with no obvious weapon and no identifiable culprit. For the astronomers who stared at its image, it was both a confounding puzzle and an irresistible invitation, an invitation to hunt for the perpetrator. To rewind the clock 500 million years and witness the cataclysm that forged this impossible ring of fire. The search for answers would require more powerful eyes, new ways of seeing the universe, and a willingness to imagine cosmic collisions on a scale previously thought to be the realm of science fiction. The quiet era of galactic classification was ending, and a new, more violent understanding of the cosmos was about to be born. The case of the Cartwheel Galaxy was officially open. What we had for so long was a portrait frozen in time, a single, magnificent, and utterly baffling snapshot of a cosmic anomaly. The questions it posed were as vast as the void it inhabited, but our ability to answer them was limited by the light we could gather. We were like detectives staring at a single grainy photograph of a crime scene, able to see the aftermath but utterly blind to the sequence of events that had led to it. The serene, static portrait of the universe, where galaxies evolved with the glacial patience of eons, offered no explanation for this chaotic masterpiece. To unlock its secrets, to transform this static image into a living story, we needed more than just a better lens. We needed to see in ways we had never seen before. We needed to perceive the invisible. That revolution in sight began not on Earth, but hundreds of miles above it, in the silent, unforgiving vacuum of space. The launch of the Hubble Space Telescope was more than a technological achievement. It was the unblinking eye we had dreamed of for centuries, free from the turbulent, distorting blanket of our own atmosphere. Suddenly, the universe snapped into focus with a clarity that was almost overwhelming, and when Hubble turned its gaze towards that strange, distant wheel of stars, the picture it returned was breathtaking. The grainy photograph became a high-resolution chronicle of cosmic history. What was once a mottled, indistinct ring of light was now resolved into a firestorm of individual, searingly bright blue jewels. Each one of those points of light was a colossal young star, a stellar newborn burning with ferocious intensity. This was our first profound clue. These were not ancient placid suns. These were galactic infants, O-type and B-type stars, titans 100 times more massive than our own sun and millions of times more luminous. Such stars are notoriously short-lived. They are the brilliant rock stars of the cosmos, burning through their vast reserves of fuel in a cosmic heartbeat, only to die in the cataclysmic supernova explosions that seed the universe with heavy elements. To find an entire ring, 150,000 light-years across, absolutely saturated with these ephemeral giants, was to find a celestial nursery of impossible scale. This wasn't the gentle, sporadic starbirth we see in the serene arms of our own Milky Way. This was something else entirely. It was a frantic, synchronized conflagration, a chain reaction of creation on a galactic scale. The sheer density of these blue stars told us without question that this event, whatever it was recent. The stellar evidence screamed that no more than a few 100 million years had passed since the ring was forged. The cartwheel was not an ancient artifact. It was the smouldering ember of a very recent and very violent event. But visible light, even Hubble's pristine view, only tells part of the story. To truly understand the engine driving this inferno, we had to peel back another layer of reality. We turned to instruments that could perceive the universe not in the gentle photons of visible light, but in the warm glow of infrared. When we look at the universe in infrared, we are no longer seeing just the starlight, we are seeing the heat. We are seeing the vast, cool clouds of dust and gas that are the raw ingredients for new worlds and new suns. It is a view into the hidden architecture of creation, and when the Spitzer Space Telescope and later the James Webb Space Telescope stared into the heart of the Cartwheel's ring, the view was utterly transformative. The outer ring, already spectacular in visible light, now appeared as a raging incandescent furnace. The infrared view revealed that this was not just a collection of stars, but a churning, roiling tempest of star-forming nebulae, each one a cauldron of gravitational collapse. We could see the shock and awe of physics in action. We were witnessing a colossal wave of pressure, a cosmic tsunami of compressed hydrogen gas sweeping outwards from the galaxy's center at over 200,000 miles per hour. This wave, like a celestial snowplow, was crashing into the sparse gas of the galaxy's outer disk, piling it up, squeezing it beyond its breaking point, and triggering that furious galaxy-spanning burst of starbirth. It was a ring of fire, a celestial blowtorch setting ablaze everything in its path. The implication was staggering. This was not a structure that had grown peacefully over billions of years. This was the immediate, explosive consequence of some unimaginable kinetic event, a shockwave propagating through the very fabric of the galaxy. The evidence was beginning to accumulate, painting a picture of a system profoundly disturbed. A quiet galaxy does not simply erupt in a synchronized ring of fire. But if the outer ring was the site of explosive creation, what of the galaxy's core? What story was hidden within that inner, misshapen circle of light? To answer this, we needed to look at the universe in its most violent and energetic wavelengths, X-rays. Orbiting observatories like the Chandra X-ray Observatory are designed to see the universe of extremes. They detect the superheated gas of exploding stars, the tortured matter spiraling into black holes, the highest energy phenomena the cosmos can produce. They see the universe's scars. When Chandra stared at the cartwheel, the serene portrait was shattered for good. The galaxy was aglow with high-energy radiation. The core and the inner ring were peppered with dozens of ultraluminous X-ray sources. These are not normal stars. They are the telltale signs of stellar corpses, neutron stars, and black holes, locked in a gravitational death dance with a companion star. As the compact remnant strips material from its partner, that matter is superheated to millions of degrees, unleashing a torrent of X-rays before it disappears forever. The sheer number of these violent systems was another critical piece of the puzzle. They are the direct descendants of the massive, short-lived stars that supernovae create. To find so many meant that the core, just like the outer ring, had also experienced a dramatic burst of star formation in its recent past. It was a second, older ripple from the same catastrophic event, but it was the very shape and structure of the core, as seen by Hubble, that spoke most eloquently of violence. It was not the elegant, ordered bulge of a typical spiral. It was a wreck. The inner ring was clumpy, broken, and off-center, as if it had been fundamentally knocked askew. The spokes of dust and gas that connected the inner ring to the outer one were not the graceful, curving arms of a spiral galaxy. They were chaotic, transient filaments, like the temporary patterns formed when a stone is dropped into a still pond. They were the visible reverberations of the impact, a system still oscillating, still trying to find its gravitational equilibrium after receiving a devastating blow. The galaxy's heart was not just disturbed, it was wounded. It had been physically punctured, and we were seeing the scar tissue. Putting these pieces together, the youthful fire of the outer ring, the violent X-ray glow, and the shattered structure of the core, an unavoidable hypothesis began to form in the minds of astronomers. The static view of galaxies was dead. This object was not a rare, stable species of galaxy. It was a crime scene. The cartwheel was the victim of a colossal cosmic hit and run. Something another galaxy must have plunged directly through its heart. The idea was as elegant as it was violent. A smaller galaxy acting as a gravitational bullet would pass through the larger spiral disk. Almost like a ghost, its stars rarely colliding directly with the target stars due to the immense space between them, but its gravity would be another matter entirely. The immense gravitational field of the intruder galaxy as it passed through would have pulled material inwards towards the point of impact. Then, as the intruder exited the other side, that piled up gas and dust would rebound outwards in a colossal, expanding density wave. This was the shockwave we were seeing. This was the cosmic tsunami that triggered the Ring of Fire. It was a ripple not of water but of space-time itself, propagating through the galactic disk and igniting the stellar nurseries. It explained everything. It explained the fiery young outer ring, which was simply the leading edge of this expanding wave of creation. It explained the disturbed core, the point of impact still reeling from the violence. And it explained the spokes, the transient filaments of material still falling back inwards after the initial disruption. It was a beautiful, powerful theory, but to prove it, we needed to find the weapon. We needed to find the bullet. A cosmic hit and run requires an intruder, and for a long time we couldn't definitively identify it among the small companion galaxies nearby. The final damning piece of evidence would come from a completely different part of the electromagnetic spectrum, from a view of the universe that is utterly alien to our senses. we turned to radio telescopes, immense dishes designed to capture the faint, long-wavelength whispers of the coldest, most diffuse material in the cosmos, neutral hydrogen gas. This gas is the fundamental fuel for all star formation, the vast, invisible reservoir from which galaxies are built. In a normal spiral galaxy, this gas forms a vast, flat rotating disk extending far beyond the visible stars. When astronomers used instruments like the Very Large Array to map the hydrogen gas around the Cartwheel, what they found was the smoking gun. They did not see a neat, orderly disk. Instead, they discovered vast, ghostly tendrils of hydrogen stretching for hundreds of thousands of light-years through intergalactic space. These were not random clouds. They formed a distinct, unmistakable bridge, a gravitational breadcrumb trail connecting the mangled Cartwheel to one of its small companion galaxies, a blue compact dwarf designated G3. It was an umbilical cord of gas pulled and stretched between the victim and its assailant during the violent encounter. This was the cosmic ghost the material trail left in the wake of the intruder as it fled the scene. We could now trace its path, see where it had come from, and witness the gravitational damage it had left in its wake. There was no longer any doubt. The case was closed, and yet 1,000 new questions bloomed in its place. We had assembled the clues from the infrared fire, the X-ray scars, and the radio ghost, and they all pointed to a single dramatic conclusion: a catastrophic collision. The static, peaceful portrait of the cosmos had been replaced by a dynamic, violent, and far more interesting reality. One where galaxies are not isolated islands, but interact, collide, and transform one another in spectacular fashion. We had solved the what. The Cartwheel was a transient, spectacular phase in the life of a galaxy that had survived a direct bullseye impact. But solving the what only made the question of how more urgent and more complex. Knowing a collision happened is one thing. Understanding the precise physics required to create such a perfect symmetrical ring is another entirely. A simple smash-up would create a mess, an irregular train wreck of a galaxy. But this was art. It implied an impact of incredible precision. What was the exact mass of the intruder? What was its velocity? What was the angle of entry? Was it a perfect head-on strike right through the galactic nucleus? A glancing blow would have resulted in a warped, one-sided spiral, not this astonishingly symmetrical wheel. The universe, it seemed, had performed a feat of cosmic archery of almost impossible accuracy. The evidence had led us to the precipice of understanding, giving us the outline of the story. But to fill in the details, to truly recreate the moment of impact and watch this cosmic ring of fire bloom from the chaos, we would have to leave the realm of observation and enter the world of pure mathematics. We would have to build a universe inside a machine. And so the puzzle remained suspended in the silent expanse between galaxies. We had the evidence of a cataclysm, a cosmic fingerprint pressed into the very structure of space-time, but the story it told was incomplete. The theories we possessed felt inadequate, like trying to explain a symphony with a single note. An explosion from a supermassive black hole might account for an expanding shell of gas, but it couldn't sculpt the delicate star-laced perfection of the Cartwheel's ring, nor could it explain the eerie persistence of the galactic core so seemingly undisturbed amidst the chaos. The traditional models of slow, elegant gravitational dances between galaxies, the graceful mergers that build majestic spirals over billions of years, were equally powerless. They were tools designed to describe a waltz, and what we were witnessing here was a celestial car crash, a violent head-on impact of unimaginable force. The answer, it turned out, would not be found by looking deeper into the sky with conventional telescopes alone. To truly solve this crime, we had to build a new kind of universe, not of glass and steel, but of pure information. We had to construct a ghost of the cosmos inside a machine. The era of computational astrophysics was dawning, and with it came a revolutionary power, the ability to manipulate time itself. Inside the humming cores of the world's most powerful supercomputers, scientists could finally do what generations of astronomers had only dreamed of. They could take the fundamental laws of the universe, the unyielding equations of gravity, the complex fluid dynamics of interstellar gas, the precise triggers for stellar ignition, and use them as the source code for a digital reality. They could create a virtual galaxy, a swirling disk of billions of digital stars and suns, and then with a few lines of code they could hurl another galaxy at it. They could rewind the event, play it in slow motion, or watch it unfold from any angle in the synthetic cosmos. It was the ultimate laboratory, a place where you could stage galactic collisions without waiting millions of years for the results. But this power was not easily wielded. Early simulations were crude, ghost-like approximations of reality. They treated vast clusters of stars as single points of light and smeared clouds of gas into uniform blobs. The computational power required to track the intricate individual gravitational pull of every single star on every other star was and still is beyond our reach. These initial models were like blurry, out-of-focus photographs of the real thing. They could show a disturbance, a general disruption, but they failed time and again to reproduce the razor-sharp definition of the Cartwheel's ring or the fragile, enigmatic spokes that connected it to the core. The digital ghost refused to look like the real thing. For the simulations to become a true key, they needed a clearer target to aim for a more detailed map of the crime scene. That map would be delivered by an instrument that has more than any other defined our modern view of the cosmos, the Hubble Space Telescope. Lifting its gaze above the distorting shimmer of Earth's atmosphere, Hubble provided a view of the Cartwheel with unprecedented, breathtaking clarity. For the first time, we weren't just seeing a blurry ring, we were resolving individual brilliant blue knots of star formation. These were the stellar nurseries, the birthing grounds of new suns blazing with the fierce, ephemeral light of young, massive stars. The ring Hubble showed us was not a solid object, but a vibrant, living wave of creation. The inner core, too, gave up its secrets. It was revealed to be a much older, more settled collection of yellowish stars, the surviving heart of the original galaxy. And most tantalizingly, Hubble captured faint filamentary structures, the delicate spokes of gas and dust stretching across the void between the nucleus and the outer ring. These were not solid bars of stars, but transient ghostly tendrils, a crucial clue that hinted at a dynamic, ongoing process. This flood of high-resolution data was the missing ingredient. Now the theorists and the simulators had their ground truth. The goal was no longer to create a vague ring shape. It was to build a digital model that could precisely replicate the brilliant blue starburst in the outer ring, the quiescent yellow core, the vast empty space between them, and those impossibly delicate spokes. The challenge was immense, but the target was finally in focus. With this new, fantastically detailed blueprint, a new generation of simulations began. Scientists at institutions around the world fed the refined data into machines that were themselves orders of magnitude more powerful than their predecessors. They modeled not just gravity, but the behavior of galactic gas, how it heats up when compressed, how it cools down, and how, when it reaches a critical density, it collapses to ignite into a star. They ran thousands of iterations, a relentless process of cosmic experimentation. They varied the size of the target galaxy, a large, gas-rich spiral much like our own Milky Way may have been billions of years ago. Then came the projectile. They programmed a small, compact galaxy, a dwarf galaxy, to be the bullet, and they began to test every conceivable angle of attack. A grazing blow. The simulation showed the spiral arms being torn and distorted into long tidal tails, a beautiful but incorrect result. An off-center strike. Again, a lopsided, messy remnant, bearing no resemblance to the Cartwheel's near-perfect symmetry. The answer the simulations were screaming had to be something far more specific, far more violent, and far more rare. It had to be a direct hit, a bullseye. Imagine the scene, a darkened room lit only by the glow of a computer monitor. For weeks, perhaps months, a researcher has been nurturing their digital universe, adjusting the initial conditions, launching the simulation, and waiting hours or days for the machine to crunch the numbers and render the outcome. Most runs end in failure, producing chaotic, unrecognizable smears. But then, one simulation begins to look different. On the screen, a majestic spiral galaxy, its arms laden with digital gas clouds, turns serenely. From the void below, a smaller, denser galaxy approaches a gravitational cannonball. It doesn't skim the edge, it doesn't strike a glancing blow. It plunges directly through the larger galaxy's core like a stone dropped through the surface of a pond. For a moment there is chaos. The core of the spiral is violently compressed, its structure momentarily shattered. But the bullet galaxy, being smaller and more compact, holds together and passes straight through to the other side, continuing its journey into the digital void. Behind it, it leaves not a hole but a ripple. A silent gravitational thunderclap expands outwards from the point of impact. This is the moment of genesis. This is the smoking gun. This ripple is not made of matter in the conventional sense. You cannot see the wave itself. It is a density wave, a powerful expanding shock front of pure gravitational compression. Think of it as a cosmic tsunami traveling not through water, but through the very fabric of the galaxy's interstellar medium. As this invisible wave expands from the violated core, it acts like a snowplow, gathering up the vast diffuse clouds of hydrogen gas and cosmic dust that permeate the galactic disk. It sweeps them up and compresses them with unimaginable force. And in the universe, when you violently squeeze a cloud of cold hydrogen gas, only one thing can happen: it ignites. The compression triggers a chain reaction, a synchronized galaxy-wide detonation of star birth. Billions of new stars are born almost simultaneously along this expanding front. And because the most massive stars burn the hottest and brightest with a brilliant blue-white light, the expanding density wave becomes visible to us 500 million light-years away as a spectacular luminous ring of fire. It is a celestial baby boom writ large across the heavens. The simulation on the screen now mirrors reality with stunning fidelity. There is the old yellow core which has now resettled after the intruder's passage. There is the vast empty zone swept clean of gas by the expanding shockwave. And there, at the leading edge of the wave, is the brilliant blue ring of furious star formation. Even the spokes appeared in the more sophisticated models, revealed to be transient instabilities, channels of gas beginning to fall back towards the galactic center after the wave had passed, like the fleeting patterns in the splash of a water droplet. It was all there, a perfect match. The ghost in the machine had finally shown us the truth. The Cartwheel Galaxy was not an object, but an event, the immediate aftermath of a cosmic bullseye. This breakthrough was more than just a beautiful piece of theoretical work. It provided a testable prediction. If a bullet galaxy had truly passed through the Cartwheel's core, it wouldn't have just vanished. It would still be out there somewhere in the vicinity, speeding away from the scene of the crime. The simulations could even predict its likely trajectory and current location hundreds of millions of years after the impact. Astronomers now knew exactly what they were looking for: a small, compact galaxy showing signs of disruption, located along a specific vector leading away from the Cartwheel. They turned their telescopes to the region of space surrounding the ringed behemoth, and almost immediately they found not one but two potential culprits, small companion galaxies designated G1 and G2. The hunt for the specific instigator was on. At first glance, both seemed like plausible candidates, battered accomplices to the main event. But as observations deepened and the simulations were refined to match the specific orientation of the Cartwheel system, the evidence began to point overwhelmingly to one of them. Galaxy G1 was larger and further away, and its calculated trajectory didn't quite line up with the elegant symmetry of the ring. It seemed to be a more distant and likely innocent bystander. But G2, a smaller and more distorted galaxy, fit the profile perfectly. Its position in space and its velocity relative to the Cartwheel aligned precisely with the path predicted by the bullseye collision model. The timing was perfect. Its current distance from the Cartwheel was consistent with a galaxy that had passed through the core roughly 200 to 300 million years prior, which is exactly the calculated age of the starburst ring. Further observations with radio telescopes revealed the final damning piece of evidence: faint streamers of hydrogen gas, invisible to the naked eye, forming a tenuous bridge connecting the Cartwheel to this smaller companion. It was the wreckage trail, a ghostly wisp of gas pulled from the larger galaxy during the violent passage, tying the victim to its assailant across 100,000 light-years of space. This was it. The case was closed. We had found the bullet. The Cartwheel was no longer a static portrait of a strange galaxy, but a freeze frame of a dynamic and violent process. We were witnessing in real time the consequence of a cosmic hit and run. The solution to the puzzle was profoundly elegant and deeply unsettling. It revealed that galaxies are not the serene, isolated islands of light we once imagined. They are active, dynamic participants in a universe filled with violent encounters. The very structure of a galaxy can be completely rewritten in a geological blink of an eye. This discovery transformed our understanding, showing us that such collisions, while rare, are a powerful engine of galactic evolution. They can trigger bursts of star formation so intense they can consume a galaxy's entire reservoir of gas, fundamentally altering its future development. The Cartwheel, once a quiet spiral, was now a blazing ring of fire, its destiny forever changed by a single catastrophic encounter. The serene image we see through our telescopes belies a history of immense violence and a future shrouded in uncertainty. Having identified the cause of this magnificent wound, a new set of questions began to demand answers. What becomes of a galaxy after such a trauma? What is the ultimate fate of this spectacular but ultimately fleeting ring of light? The story of the impact was over, but the story of the aftermath of the galaxy's long, slow recovery was only just beginning. And so the cosmic trigger has been pulled. The smaller galaxy, a phantom of dark matter and stars, has plunged directly through the heart of the Great Spiral, an act of unimaginable violence conducted in the silence of the void. But the true spectacle, the birth of the Cartwheel, is not in the moment of impact. It is in the thunderous echo that follows a ripple of gravitational fury that is now reshaping an entire island of stars. To understand this transformation, you have to imagine something beyond a simple collision, beyond the mere shattering of matter. You have to visualize a wave not of water but of gravity itself. A gravitational tsunami born from the sudden, violent compression at the galaxy's core, now propagating outwards through the delicate galactic disk. This is the density wave, the master sculptor of this cosmic catastrophe. As the intruder galaxy punched through its immense gravity, acted like a piston, momentarily dragging trillions of stars and vast clouds of gas inwards towards the point of passage. For a fleeting cosmic instant, the galactic center became unimaginably dense, a fleeting concentration of mass and energy. But the universe abhors such imbalance. This central compression couldn't hold. What followed was not an explosion in the traditional sense, but a rebound, a powerful outward surge. This surge is the wave. It isn't a wave of material flying outwards like shrapnel. The stars themselves are not projectiles. Instead, it is a wave of time's information, times a pulse of pure gravitation, expanding at a staggering 300,000 kilometers per hour. Picture the galactic disk as a placid field of grain. The density wave is the wind sweeping across it. The individual stalks of grain, the stars are jostled, but they largely remain rooted in place. They rise and fall with the passing gust, their orbits momentarily perturbed, slightly stretched and altered, before they settle back into a new equilibrium. But the loose chaff, the clouds of interstellar gas and dust that drift between the stars, are not so firmly anchored. They are swept up, carried along, and brutally compressed by the advancing front of the wave. This distinction is the absolute key to the Cartwheel's fiery ring of creation. The stars feel a gravitational nudge, but the gas feels a colossal, irresistible shove. This wave of compression, this gravitational shockwave, is the engine of renewal. Before the collision, this galaxy was likely a serene spiral, much like our own Milky Way. Its vast, tenuous clouds of hydrogen gas, the raw fuel for star birth, were in a delicate balance. They drifted for eons, too diffuse and too warm to collapse under their own gravity. They needed a trigger, a cosmic kick to begin the process of creation. The density wave is that trigger on the most epic scale imaginable. As this wall of gravity slams into a quiescent nebula, it squeezes it with unimaginable force. The cloud, once spanning light years, is crushed down to a fraction of its size. Its density skyrockets, crossing a critical threshold known as the Jeans instability, the point of no return for a cosmic gas cloud. At this point, the cloud's own internal gravity overwhelms its gas pressure. It can no longer support itself against its own weight, and a chain reaction of collapse begins. The cloud fragments into thousands, then millions of dense cores. Within each core, pressure and temperature climb relentlessly. The cold, dark hydrogen gas begins to glow, first a dull red, then a brilliant yellow-white. The temperature at the very center of each core soars past 10 million degrees Celsius. And then it happens. Nuclear fusion ignites. A star is born. This process is not happening in one or two isolated nebulae. It is happening all along the entire circumference of the expanding wavefront, a synchronized galaxy-wide firestorm of creation. This is what we are seeing in that magnificent blazing blue outer ring. It is not just a structure, it is an event, a process unfolding before our eyes across 500,000 light-years. The brilliant blue and ultraviolet light is the telltale signature of newborn stars, specifically the most massive and luminous types known as O and B-type stars. These are the titans of the cosmos, celestial blowtorches dozens of times more massive and hundreds of thousands of times brighter than our Sunday. They burn through their nuclear fuel with a ferocious intensity, living short, spectacular lives that last only a few million years, a mere blink of an eye in galactic time. Their presence is the smoking gun, irrefutable proof that we are witnessing a colossal ongoing starburst. The outer ring of the Cartwheel is one of the most extreme stellar nurseries in the local universe, a testament to the creative power of destruction. The evidence for this incredible story is not confined to simulations on a supercomputer. It is etched into the very light of the galaxy itself, a cosmic story waiting for us to read. When we point our most powerful telescopes like the Hubble and now the James Webb Space Telescope at the Cartwheel, we are not just taking a picture, we are performing a cosmic autopsy. By carefully analyzing the spectrum of light from different parts of the galaxy, we can do something remarkable. We can determine the age of the stars. The light from the outer ring is overwhelmingly dominated by those young blue giants. They are infants no more than a few million years old, confirming that they must have ignited as the wave passed through their location. Move your gaze inwards into the space between the rings, and the stellar population changes dramatically. Here the stars are older, redder, and more sedate. They are the original inhabitants of the galaxy, the survivors of the collision who were gravitationally jostled but not recently created. This clear age gradient from young on the outside to old on the inside is precisely what the density wave model predicts. It's like seeing concentric rings of fresh growth on a tree stump after a forest fire. We are watching the wave propagate outwards in slow motion, written in the age of the stars it leaves in its wake. Furthermore, the James Webb Space Telescope, with its extraordinary infrared vision, has pierced through the dust to give us an even more intimate view. It has revealed intricate pockets of star formation, filamentary structures of gas, and the chemical composition of the regions where new solar systems are being born. We see hydrocarbons and silicates, the very building blocks of planets, being churned up and incorporated into this new generation of stars and their nascent worlds. The simulations told us what should be there, and our telescopes are now showing us that it is. The theory and the observation are locked in a beautiful, confirming embrace. But what of the galaxy's original elegant form? A spiral galaxy is a masterpiece of gravitational balance, its arms traced by slightly denser waves of stars and gas that orbit the center. The collision that created the Cartwheel was a cataclysm that utterly shattered this delicate structure. The outgoing circular density wave was so powerful, so fundamentally different in its geometry, that it completely overran and erased the pre-existing spiral pattern. Imagine dropping a massive boulder into a pond, where tiny gentle ripples are already present. The immense circular wave from the boulder's impact simply obliterates the smaller patterns, subsuming them into its own powerful motion. This is what happened to the Cartwheel's spiral arms. They were stretched, torn apart, and their constituent stars and gas were reorganized into the new ring-like configuration. Yet a ghost of that former self remains. Look closely at the Cartwheel, and you will see faint, spoke-like structures stretching from the bright inner ring to the chaotic outer one. For a long time, these were a puzzle, but our models now show that these spokes are likely the distorted, drawn-out remnants of the original spiral arms. They are fossil structures, galactic scar tissue, that testifies to the galaxy's previous life. As the density wave expanded, it didn't just erase the arms, it dragged material along with it, pulling the arms into these strange, transient radial features. They are temporary, and over the next few 100 million years, they will likely fade away, leaving the two rings to evolve on their own. We are lucky to be observing the Cartwheel at this specific moment, a time when the evidence of its past is still faintly visible amidst the chaos of its present. However, for all that we have unraveled, the Cartwheel still holds its secrets with a gravitational grip. The model of the expanding density wave brilliantly explains the colossal outer ring, but it struggles to fully account for the second inner ring. This feature is a profound puzzle. It is much smaller, more compact, and composed of significantly older stars than its boisterous outer sibling. There isn't a torrent of new star formation here, so if the primary wave has already passed this region, why is there a distinct, stable ring of material left behind? What sculpted this second fainter circle? One leading idea posits that the inner ring is a form of gravitational splashback. After the initial violent compression and outward rebound, some of the gas and stars that were dragged inwards didn't have enough velocity to escape. They fell back towards the galactic center, piling up at a certain distance, where their angular momentum created a stable orbiting structure. It's like the secondary ripple you sometimes see in a pond, a smaller echo that follows the main wave. This model fits some of the observations, particularly the presence of gas, but it doesn't perfectly explain the ring's apparent stability and distinct edge. Another more complex theory suggests the inner ring is a resonance phenomenon. In this scenario, the massive gravitational disturbance from the collision has excited a natural harmonic frequency within the galaxy's stellar disk. Just as a guitar string can vibrate at multiple distinct frequencies to produce overtones, the disk of stars can sustain certain stable ring-like orbits at specific distances from the center. The inner ring, according to this hypothesis, represents one of these gravitational sweet spots, a place where stars have naturally settled into a long-lived resonant pattern following the primary disturbance. Teasing apart these possibilities requires even more sophisticated simulations and more detailed observations of the velocities and compositions of the stars within that mysterious inner structure. It is a puzzle that reminds us that even when we think we have the answer, the universe often reveals another layer of complexity. And then there is the final tantalizing mystery, the identity of the assailant. The simulations tell us a smaller galaxy passed through the heart of the spiral. But which one? Where is it now? Peering into the space around the Cartwheel, we see several smaller companion galaxies. Two of them, designated G1 and G2, are the prime suspects in this cosmic hit and run. They are at roughly the right distance, and their motions are generally consistent with them having recently passed through the larger galaxy. But proving the case beyond a reasonable doubt is fiendishly difficult. We are seeing a two-dimensional snapshot of a three-dimensional event that unfolded over hundreds of millions of years. Tracing their trajectories back in time is an exercise fraught with uncertainty. We have to account for the gravitational pull of the Cartwheel itself, the influence of other nearby galaxies, and the vast halos of invisible dark matter that enshroud them all. Current evidence slightly favors the galaxy known as G2, but the case is far from closed. It's possible the true culprit is another smaller and darker galaxy that our telescopes have not yet definitively identified. Or perhaps one of these companions is not the bullet but another victim, its own structure warped by a near miss with the Cartwheel system. This lingering whodunit is a thrilling aspect of the investigation. We have found the stunning scene of the crime. We have figured out the physics of how it was done, but the culprit may still be hiding in plain sight, its true role in this grand cosmic drama, yet to be fully confirmed. The Cartwheel, born of violence, still cradles these profound questions within its fiery rings, each one a challenge to our understanding and a lure for future exploration. It stands as a powerful reminder that for every stunning revelation the cosmos offers it presents a new and deeper enigma, pulling us further into its magnificent unfolding story. And so, with the fragments of evidence assembled, the cosmic ghost story finds its voice. The scattered clues we have meticulously gathered, the ghostly filaments seen in infrared, the fierce cadence of star birth, the invisible architecture of dark matter, all begin to lock into place. They cease to be disparate facts and become verses in a single epic saga of unimaginable violence and breathtaking creation. The puzzle of the Cartwheel, which once seemed an unsolvable enigma, is now ready to yield its deepest secrets. We can finally wind back the cosmic clock not just for thousands or millions of years, but for over 200 million. We are about to become witnesses to the cataclysm. Let us journey back to that primordial moment before the fire, before the ring, to a time when our galaxy was just another quiet island of stars adrift in the silent ocean of the intergalactic void. Imagine it then. A vast, majestic spiral galaxy, much like our own Milky Way, turning with a silent, stately grace that had defined it for billions of years. Its arms, luminous with the gentle light of mature stars, were delicate rivers of cosmic dust and cool, quiescent gas. This was a galaxy in its serene middle age, a place of order and predictability where stars were born, not in furious bursts, but in a slow, steady rhythm. Its gravitational heart was a stable, well-ordered core, a gyroscope of suns holding the entire structure in a delicate spinning embrace. For eons, nothing had disturbed its celestial peace. But it was not alone. Across the unimaginable gulf of space, another galaxy, a far smaller and denser entity, was on a collision course. This was no gentle merger, no slow, graceful dance of two titans spiraling together over a billion years. This was an ambush. The intruder, perhaps a dwarf galaxy 1/10 the mass of the primary, was a gravitational bullet drawn by the invisible web of dark matter that connected them both. It wasn't aiming for a glancing blow on the outskirts. Its trajectory was impossibly fatally precise. It was aimed directly at the heart. As the two galaxies closed the final million light-years between them, the larger spiral would have felt the first subtle strains of the impending disaster. Tides of gravity, faint at first, would have begun to stretch and warp its outermost arms. The delicate symmetry of the disk would have started to twist, a prelude to the chaos to come. The smaller galaxy, compact and relentless, accelerated its own gravitational field, punching a hole in the serene dark matter halo of its victim. There was no sound, no explosion in the traditional sense, only the silent, inexorable math of physics playing out on a scale that defies human comprehension. The final moments would have been a terrifying spectacle of distortion. The intruder plunged through the spiral's gaseous halo, a tenuous outer atmosphere of superheated plasma, like a stone skipping across the surface of a pond. Except this stone was not skipping, it was diving. Then, in a single brutal instant, it struck the main disk. This was not a collision of solids, but an interpenetration of entire systems. Stars separated by light years mostly passed by one another like phantom ships in the night. But the gas, the vast diffuse clouds of hydrogen and helium that permeated the spiral's arms, had nowhere to go. The moment of impact was a moment of supreme compression. The intruder galaxy, traveling at a staggering speed of over 500,000 miles per hour, acted like a piston, a gravitational plunger driven through the very soul of the larger galaxy. The gas in its path was instantaneously and violently compacted, heated to millions of degrees, and ionized into a state of incandescent fury. It was a cosmic sonic boom, not of sound but of density and energy propagating outwards from the point of entry. In that fraction of a cosmic second, the ordered rotating disk of gas was transformed into a chaotic pressurized cauldron, but the intruder didn't stop. It pierced the core, a disorienting journey through the densest stellar region, and shot out the other side, leaving a gaping, gravitationally unstable tunnel in its wake. The victim galaxy was mortally wounded, its heart pierced, its structure fundamentally and irrevocably broken. Yet in that act of destruction, something extraordinary was about to be born. The energy of that impact did not simply dissipate, it was transformed. It became a wave. This was the genesis of the Great Outer Ring. The colossal shockwave born from the impact, a gravitational tsunami, began to expand outwards from the violated core. It was a ripple, yes, but not in water. This was a ripple in the very fabric of space-time, and the interstellar medium, a relentlessly expanding circle of pure force. Propagating at over 200,000 miles per hour, this wave swept through the galaxy's disk like a cosmic snowplow. Ahead of it lay the serene, undisturbed clouds of cold hydrogen gas, the raw fuel for star formation that had lain dormant for ages. As the shock front, a wall of unimaginable pressure slammed into these clouds, it compressed them beyond their breaking point. Gravity, which normally takes millions of years to patiently coax gas into stellar nurseries, was given a violent and immediate command. Pockets of gas that were once diffuse and stable were instantaneously crushed into dense knots, triggering their gravitational collapse on a scale almost impossible to imagine. This was not starbirth, it was a star-forming detonation. All at once, across a circular front, stretching for tens of thousands of light years, the galaxy ignited. Millions of massive, brilliant blue stars flared into existence, their light a fierce, searing testament to the violence of their conception. You are witnessing the formation of the Cartwheel's Ring of Fire. This magnificent luminous structure, which gives the galaxy its name and its breathtaking beauty, is nothing less than the crest of that initial shockwave, frozen in time for our telescopes to see. It is the luminous scar of the impact, a celestial ring of stellar newborns, whose collective light outshines everything around them. These are not gentle, long-lived stars like our Sun. They are colossal blue-white giants, dozens of times more massive, burning through their nuclear fuel with a reckless intensity. Their lifetimes are brutally short, measured in mere millions of years before they too will detonate as supernovae, further enriching and churning the gas around them. What we see in that brilliant blue light is the flash of a generation, a single synchronized wave of creation sweeping across the galaxy. The shockwave itself is invisible, but its effect, this ring of furious star formation, is one of the most spectacular sights in the entire universe. But the story does not end with this single magnificent ripple. If it did, we would see only one ring. The existence of the second inner ring and the chaotic nature of the core pointed to a more complex, more protracted aftermath. The initial splash model, while brilliant, was incomplete. The universe we have found is rarely so simple. After the primary shockwave blazed its trail towards the galactic edge, a new force began to assert itself: gravity's relentless tendency to reclaim what was lost. The material that was violently thrown outwards by the initial impact did not simply escape forever. Much of it caught in the deep gravitational well of the galaxy's central mass, and its dark matter halo began to slow, halt, and then fall back inwards. It was a cosmic rebound, an inhalation after a devastating exhalation. This inward cascading material, a torrent of gas and dust raining back down upon the wounded core, created a traffic jam of cosmic proportions. As it fell, it piled up, creating a second distinct density wave. This wave, unlike the first, did not propagate outwards. It was an aftershock that rippled inwards, or perhaps stalled a concentration of matter that formed a temporary gravitational dam. Here too, the conditions became ripe for another smaller burst of star formation. This gravitational recoil is the architect of the Cartwheel's inner ring. It is not a direct result of the initial impact, but a secondary consequence, an echo of the primary event that took millions of years to manifest. It is a testament to the complex oscillating physics of a gravitationally shattered system. And what of the mysterious spokes, the ghostly filaments that JWST's infrared eyes revealed stretching between the rings? They too are part of this rebound narrative. These are not solid structures, but immense rivers of gas and dust being funneled along the gravitational pathways carved out by the collision. They are the skeletal framework of the galaxy laid bare by the event. As material falls back towards the center, it doesn't do so uniformly. Instead, it is channeled along these dense filaments like water flowing down the grooves of a corrugated surface. These spokes are the visual evidence of the galaxy's slow, agonizing attempt to piece itself back together, the arteries, feeding the chaotic heart with recycled gas. They show us that the Cartwheel is not a static object, but a dynamic breathing system, still reeling, still flowing, still reacting to a catastrophe that occurred 250 million years ago. Finally, we turn our gaze to the very center, the ground zero of the collision. What we find there is not a galactic nucleus, but a galactic wound. The core is a maelstrom of activity, a chaotic mix of old pre-existing stars jostled into wild, eccentric orbits, and new, younger stars born from the churning and falling gas. The neat, orderly rotation of the original spiral's center is gone, replaced by a turbulent frenzy. This is the exit wound left by the intruder, a region of profound gravitational instability where the galaxy's gyroscope was shattered. Clumps of star-forming regions flicker and flare within this chaotic zone, fueled by the gas being delivered down the spokes from the outer regions. It is a place of both destruction and frantic rebirth, a microcosm of the galaxy's overall state. The precise location of the intruder galaxy itself is still a matter of debate. One of the nearby smaller galaxies is the likely culprit, now continuing its journey through space itself, scarred and stripped of gas by the encounter, a cosmic hit-and-run driver, leaving behind a scene of spectacular devastation. And so the complete picture emerges. We see not just an object, but a story, a sequence of events unfolding over vast timescales. It begins with the serene spiral, unaware of its impending fate. Then comes the brutal head-on collision, a piercing blow that sends a monstrous shockwave of compression and creation blasting outwards. This wave ignites the glorious outer ring, the galaxy's ring of fire. In its wake, gravity begins its slow work of reclamation, pulling material back towards the shattered core. This recoil forges the inner ring and illuminates the dusty spokes, the galaxy's internal arteries. The core itself remains a turbulent scar, a constant reminder of the day its heart was pierced. Every feature we observe, every ring, every spoke, every burst of star formation, is a logical consequence of this one singular violent event. The mystery is solved. We have read the evidence, reconstructed the crime scene, and now understand the life story of this incredible cosmic flower born from an act of shocking violence. We have replaced confusion with clarity, and in doing so we have unveiled a process of galactic transformation that is more dramatic, more complex, and more beautiful than we ever could have imagined. But a story this epic does not simply end. A transformation this profound is not a destination, but a new beginning. We have answered the question of how the cartwheel came to be, but a new question now hangs in the cosmic silence. What happens next? What is the ultimate fate of this celestial ring of fire? And so we arrive at the end of a half-billion-year-old story. Our journey began with a question, a cosmic anomaly. We were confronted by an object that defied simple explanation. It was a phantom in the southern sky, a celestial ghost, a ring of impossible blue floating in the velvet blackness. It was a shape that whispered of some ancient cataclysmic event, a cosmic crime scene with no visible culprit, only a spectacular aftermath. We have since followed the clues, piecing together the evidence. We have chased gravitational ripples across vast oceans of time. We have sifted through the starlight for the spectral fingerprints of creation. What we have found is a story far more profound than we ever imagined. A story not just of a single galaxy, but of the very forces that shape our universe. The Cartwheel Galaxy is no longer just a beautiful curiosity. It has become a Rosetta Stone for understanding galactic dynamics. A perfect, almost impossibly clear case study in cosmic violence and rebirth. We now know with certainty that this was not a gentle, isolated evolution. This was a head-on collision, a brutal and direct physical impact. A smaller, unseen galaxy, a gravitational bullet tore through its heart. It passed through the serene, spinning disk of a primordial spiral. A phantom punching a hole directly through the fabric of a galaxy. The act itself was swift, a brief, violent, cosmic instant. But the consequences, the echoes of that impact, still resonate today. They have painted this masterpiece of destruction and creation across the heavens. That spectacular outer ring is not a structure of permanence. It is a shockwave, a tsunami of compressed gas and dust expanding outwards, a ripple propagating through the interstellar medium at over 200,000 miles per hour. It is a celestial echo of a singular violent moment. As this wall of pressure plows through the placid gas clouds of the galaxy, it triggers a firestorm of star formation on a scale that is difficult to comprehend. Every glittering blue knot of light in that ring is a stellar nursery, a furnace of young, massive, intensely hot stars burning with ferocious intensity. They are born from the chaos, living fast and dying young. Their fierce ultraviolet radiation illuminates the surrounding gas. Their powerful stellar winds sculpt the interstellar medium into new forms. They live out their brief, brilliant lives and then explode as supernovae, seeding the galaxy with the heavy elements necessary for future generations, for planets, for complexity, and perhaps for life. This is the great paradoxical truth the Cartwheel teaches us. In the cosmos, destruction is not an endpoint, it is a catalyst. The universe is not a quiet, static cathedral of stars. It is a dynamic, violent, and relentlessly creative arena. Galactic collisions, these seemingly apocalyptic events, are not aberrations. They are a fundamental engine of cosmic evolution, a primary driver of change. They are the sculptor's chisel, smashing old forms to carve out new ones. They shuffle the cosmic deck, mixing galactic material in new and interesting ways. They can transform placid spiral galaxies into chaotic starbursts, or merge them into the giant quiescent ellipticals that anchor galaxy clusters. Without these encounters, the universe would be a far less interesting place. It would be a universe of isolated, slowly fading islands of stars. Instead, we see a cosmos that is constantly remaking itself. A grand interwoven tapestry where everything influences everything else. The Cartwheel, in its magnificent isolation, is a laboratory for studying this process. It provides us with a snapshot, a moment frozen in time, where we can see the before, the during, and the after all at once. The placid older core reveals what the galaxy once was, a region of older, yellower stars, a remnant of the original undisturbed disk. The expanding ring of fire shows us the immediate explosive consequences of the impact, and the enigmatic spokes, those faint filaments of matter, connecting the inner ring to the outer, reveal the gravitational scaffolding. The underlying structure of the galaxy reasserting itself after the trauma. They are like temporary bridges of gas and dust being pulled back towards the center, a gravitational memory of the original spiral arms slowly reforming. This object has become a benchmark for our computer simulations, a testbed for our understanding of gravity, gas dynamics, and star formation. By recreating the Cartwheel in our supercomputers, we refine our models. We learn how galaxies respond to extreme stress, how they heal. We learn about the delicate balance between gravity's pull and the explosive push of starlight. Our journey to decipher its secrets is also a story of our own technology. For decades, the Cartwheel remained a faint, indistinct smudge on photographic plates, a curiosity for catalogues, but its true nature was shrouded in distance. It took the piercing vision of the Hubble Space Telescope to truly resolve it. For the first time, we saw the individual star clusters in the outer ring. We could distinguish the delicate filamentary structure of the spokes. Hubble gave us the first clear portrait of this cosmic collision. It confirmed the violent impact hypothesis and revealed the scale of the starburst. It showed us the immense energy being unleashed in that expanding shockwave. But even Hubble, for all its power, could only see so much. It operates primarily in visible and ultraviolet light, which meant that vast regions of the Cartwheel remained hidden from view. The very heart of the star-forming regions where new suns are being born is shrouded in immense, impenetrable clouds of cosmic dust. Visible light cannot escape these dense cocoons. To see inside, to witness the birth of stars directly, we needed a new kind of eye, an eye that could pierce through the veil of dust and see the universe in a different light. We needed to see the universe in the infrared, and that is precisely what the James Webb Space Telescope was built to do. When Webb turned its golden gaze towards the Cartwheel, it was a revelation. It was like putting on infrared goggles in a dark room and seeing it flooded with light. The familiar vista we knew from Hubble was utterly transformed. Webb peeled back the layers of dust, revealing the galaxy's hidden skeleton. The spokes, which appeared ghostly and ephemeral to Hubble, suddenly snapped into sharp, brilliant focus, revealing a highly organized structure. We could see they were not just random wisps of gas, but well-defined lanes. Rich with hydrocarbons and other complex molecules, the raw materials for star birth. These were the true arteries of the recovering galaxy, channeling fuel inwards. Webb's infrared vision allowed us to perform a kind of cosmic chemical analysis. Its near-infrared camera, NIRCam, sees the glow of the young stars, the same hot blue giants that Hubble saw, but now with breathtaking clarity. We can resolve individual stars and smaller clusters that were previously blurred together, allowing us to map the precise locations where the starburst is most intense. But the true revolution came from Webb's mid-infrared instrument MIRI. MIRI sees a cooler universe, a universe of glowing dust. It revealed a clumpy, chaotic spiral structure made not of stars but of silicate dust, the very same material that forms the rocky planets in our own solar system. This dusty skeleton had never been seen before. It showed us the underlying framework that was being reshaped by the collision. It was like seeing the steel girders of a building emerge from within a cloud of smoke. This view gave us a completely new understanding of the cartwheel structure. The smooth, elegant ring seen by Hubble was resolved by MIRI into a collection of churning, clumpy knots. Each knot a gigantic cloud of dust and gas collapsing under its own gravity, a powerhouse of stellar creation hidden until now. Webb allows us to dissect the galaxy layer by layer. We can distinguish between the glow of superheated dust around newborn stars and the spectral signatures of complex organic molecules in the spokes. We are essentially watching the galaxy's ecosystem in action. We can see where the fuel for star formation is located. We can see where that fuel is being consumed in the furnace of the outer ring, and we can see the processed material, the ashes and embers, being redistributed. The level of detail is simply staggering. We can measure the temperature and density of gas in different regions. We can track the shockwave's progress with unprecedented precision. We can see how it interacts with pre-existing pockets of gas, triggering new bursts. Even the core of the galaxy, the central region, yielded new secrets to Webb. What once looked like a relatively calm area of older stars is now revealed by Webb to contain its own massive hot dust clouds, indicating that even here, far from the main shockwave star formation is underway. The collision's effects are far more widespread than we ever knew. It has shaken the entire galactic system to its core, awakening it from slumber. Webb hasn't just given us a prettier picture. It has provided the missing pieces of the puzzle. The data it is sending back is the ground truth against which all our theories will be tested. Our computer simulations must now reproduce this clumpy, dusty spiral. They must account for the intricate chemical composition of the spokes. They must explain the pockets of star formation deep within the galactic center. It pushes our understanding to a new level of sophistication. And yet, for all that we have learned, the cartwheel still holds its mysteries. The story is not over. A new chapter has just begun. We still have questions, deeper questions, prompted by these new observations. What is the ultimate fate of the cartwheel? Will it eventually reform into a grand spiral galaxy once more? Or has the collision so thoroughly scrambled its structure that it will evolve into something else entirely? Will the spokes eventually coalesce into new stable spiral arms? Or will they fall back into the center, fueling a central starburst or a supermassive black hole? And what of the intruder, the phantom that caused all this? We have identified the likely culprits, two smaller companion galaxies nearby, but pinpointing which one was the bullseye and what its exact trajectory was still requires painstaking analysis and ever more powerful simulations. Knowing the mass and velocity of the impactor is crucial to fully reconstruct the history and predict the future of this magnificent system. Furthermore, the cartwheel challenges our understanding of dark matter, the invisible gravitational halo that should surround the galaxy. How did that halo respond to such a direct, violent impact? Did it get stripped away, or did it deform and slosh around like a fluid? The way the galaxy is reforming, the way the spokes are pulled back, holds subtle clues about the distribution of this unseen mass. These are the questions that will drive the next generation of astronomers. The legacy of the cartwheel is this beautiful, virtuous cycle of science, where each new discovery, each answered question only opens up a host of new, more profound inquiries. It is a reminder that the universe is not a finished book to be read. It is a story that is still being written, and we have only just learned to read the first few pages. As we look out at the cartwheel, we are not just seeing a distant galaxy. We are witnessing a process that is fundamental to our own existence. Our own Milky Way is on a collision course with its neighbor Andromeda. In about 4.5 billion years, they will meet in a cosmic dance, one that will be far more complex, a sprawling, messy merger rather than a direct hit. But the underlying physics will be the same. Shockwaves will ripple through gas clouds, triggering unimaginable bursts of star formation. The familiar constellations of our night sky will be torn asunder, and a new, larger galaxy will eventually be born from the chaos. The cartwheel then is a ghost of our own cosmic future. a preview of the magnificent violence and creation that awaits our own galactic home. It shows us that our place in the universe is not static. We are part of this grand, evolving, and sometimes violent cosmic web. Our journey from a fuzzy smudge on a photograph to the intricate, multi-layered portrait from Webb is a testament to human curiosity, to our relentless need to understand. We build these incredible machines, these extensions of our senses, not just to catalogue the stars, but to find our own place in the story, to understand the chain of events that led from a universe of simple gas, to galaxies, to stars, to planets, and ultimately to us. The Cartwheel Galaxy, hanging in the void 500 million light-years away, is more than just a ring of fire in the cosmic dark. It is an affirmation that the universe is in a constant state of becoming, a place where endings are always new beginnings, and where even the most violent collisions can give rise to breathtaking beauty. The story is written in starlight, and at last we are learning how to read it, and as we continue to gaze deeper with ever sharper eyes, we know that the cosmos has countless more secrets, more wonders, waiting for us to ask the right questions, waiting for the next great leap in our quest to know the universe and ourselves.